Hello, my name is Jeff Orton and I'm doing a little video about contours for the Boy Scouts. Contours are lines of equal elevation, and you've probably discussed contours in your Scout program when you're trying to understand about reading maps, especially the USGS topo maps. So what we're going to do here is we're going to talk a little bit about these, and let me show you how they're created and what they mean in a little bit different perspective than you might get in just looking at them on a piece of paper. So the area we're going to look at today to show this is this area on the eastern side of the Southern Sierra Mountains near the Inyo Kern Airport. Going south along 14 you come to Mojave, going east this direction you come to the city of Ridgecrest, going north you go up towards Mount Whitney. So just so you have an idea of the area you're looking at. We'll turn on the aerial photo of this area, and you can see that we have this area out here that looks relatively flat from what you can see here, and this area up here which seems to have something else going on. This is a mountainous area on the Southern Sierra Nevadas. So I wanted to give you a context of this area so you can understand what we're going to be looking at when we do contours. So first of all, let me show you the area in perspective, and we can use Google Maps to do that. So we have the eastern area over here, which is flat, and you have the western area of this that we're looking at here, which is mountains. And there's a highway down the middle, and there's the airport out there to the east. Now let me real quick take you back to the map, and I'm just going to use Google Street View to give you a little bit of a perspective on the ground, like you're actually taking a picture from the ground. So this is looking west towards the mountains, and here we are looking east out towards Ridgecrest. So you understand the area that we're looking at. Now this area can also be shown with this elevation data set. This elevation data, and we're looking at it in GIS software called ArcGIS. This GIS software can show us these elevation data sets that are created by flying a plane over the area and using radar or lasers to bounce signals off the ground and determine elevations. So in this case, we're looking at the eastern part, the Inyo Kern area, and the western part, the mountain area. And you can kind of tell by just looking at these that there's something different going on between the two. And so I can tell you that this is the flatter area and this is the more mountainous area. The different colors in these images are the computer rendering these images based on the low elevation being dark and the high elevation being light. And these are two separate images, so you get low to high or dark to light in each area. When you look at these up close, what you'll see is that each of these consists of pixels, each individual square of elevation. And these pixels of elevation, if we color them each a different color, you'll see they kind of form stripes or bands. And those bands each have, for each pixel in that band, like this pink band right here, or this blue band here, each one has the same elevation values. So let's go back to these same two data sets that you're looking at here in different color schemes, and we're going to look at them in a different piece of software called Global Mapper. Now to start with, Global Mapper, this is the same area. Here's the airport, here's a highway, and here's another road over here, the mountains and the flat desert area. Global Mapper takes that same elevation data that we were looking at in the other software and renders it into a hillshade here. Hillshade is the computer making it look like kind of artificially creating this hill image with a light coming from the north, so you can kind of see the shadows on the hills and see what is visible and what's not. So let's real quick look at what's happening with this data. It's all the same data that you saw in the other software, but this time we can click on this and look at a profile of what the elevations would be like along this line if I draw it. Starting on the west, we have the highest elevations. Starting on the east, we have the lowest elevations. And this is what you can see with this. You see that we have the high elevations over here on the mountains, and steep slopes. And as we came down here off the mountains, we ended up coming into this flat desert area. So keep that in mind before we put our contours on, and you can see how this works. Now, a contour is a line of equal elevations. So if we wanted to pick a contour at a certain elevation, we could draw that line on a mark on here. We could also draw a mark on this map. But if we draw contours, then we know that any place along that line will be at the same elevation. Much like the edge of a pond or a lake, if the water starts draining out and you see the little ridges along the edge of a lake, the same kind of thing happens for contours. Now, we can, in this software, generate contours from this elevation grid, have the computer draw lines, all the lines connecting the points of the same elevation. Right here, we could put in 50 feet for the contours. That means each one is going to be 50 feet apart vertically. If you get some noise in the background, I'm at work today, so that's what's causing the background noise. Here we can draw a box, and on that box we can delineate the area that we want to contour. And if I click OK here, it's going to take a couple minutes to draw this. So what I ended up doing is I've created it beforehand, and I can just turn that layer on. So now if you look, this line right here represents 2,250 feet above sea level. This line here is 2,500 feet above sea level. And each of these lines in between is an elevation 50 feet higher. One thing you'll notice here is out in this flat area, these contour lines are a long way apart because it takes a long distance to go up 50 feet, to get 50 feet higher above sea level. The closer you get to the mountains, the closer these lines get together because it takes a shorter horizontal distance to go up the same elevation. That's because there's a steeper slope, and slope is a representation of horizontal and vertical elevation. This changes. So let's real quick take this path tool we were looking before and do the same thing over again. Now these lines on this path show the contours. So you can see out here in this flat area, these points are far apart. This is probably a road or a canal change, why these little points are close together. But there's probably some little dip or something in that area. But you can see that out here the points are far apart, and as you get closer and closer to the mountains, they get closer together until you're on your steepest slopes. These contour lines almost on top of each other because the change in elevation is rapid. So let's look at this in 3D. So here we go. In 3D, we're looking at this same area. Out here the contours are far apart on the flat area. Here they start getting close together. So you can kind of see here how these lines of equal elevation, if you're looking at this, let's tip it down so we're almost horizontally looking at this. This line, this red line here, follows the same elevation all the way along here. Now, to help you visualize this a little bit better, let me do this. This software has the ability to act like the area is being flooded with water, like a lake's being put into place. So what we're going to do is we're going to flood this valley with water, and we are going to assume that the water is increasing by 50 feet each time I click this button. And as you can see, the way this computer renders a little jagged along the edge, but as you can see, every time the water level goes up 50 feet, it gets 50 feet higher, it approximates that contour line because that's a line of equal elevation. So I go up 50 feet, 50 feet, 50 feet, and you can see how this water is advancing, and it basically creates like the shorelines that are created by a lake if the water is going up or going down. So those contours are lines of equal elevation, and the steeper the slope, the closer they are together. Okay, so that being said, let's jump back to our 2D version of this, or looking straight down at the top, and I'm going to turn off those contours, and I'm going to turn on the USGS topo map. These topo maps are created by the federal government for our ability to see things like trails, developed areas. They're maps of the whole country, and they also have these contours on them. And you can see the lines that are the contours. They're not blue and red in this map, they're brown. But you can tell that over here it's more flat because the contours are far apart, and you can tell that these areas are mountainous. Then we're going to take this same thing and we're going to switch it into the 3D view. So you can see that when you go to use one of these topo maps, when you're in a scout troop and you're trying to look at a hike maybe, or go up a trail, you'll be able to see that, for example, this line here, or these dirt roads, they're fairly flat out in this area, and when you start looking at going up the mountains, they become much steeper. And you can tell that by the differences in the distances between contours. You can also see specific elevations, like the tops of mountains. You can't see it very well in this image because of the resolution. But you can also see how all this goes together. So if you were looking at trying to do some kind of a search and rescue, or you wanted to do some kind of a hike or a camping event, you could tell by looking at these USGS maps that what the elevation was and how they went together. So that's my computer telling me that I have a meeting coming up, so I'm going to call that good, and I hope that this helps you understand better the USGS Topo Quad map. Thank you.